Hello community, so great that you are back. Now after a week that we talked only about textual reasoning, now let's advance the complexity and let's include visual reasoning. So everything from images to short videos. What could go wrong if we look here at the latest AI research? So let's start by a simple example. So here this image and I say, hey, find the tool that I would use to loosen here a rusty bolt. Now, you might go with an object detector and AI system that will find all the different tools. Or you will go with a segmentation model that might not understand at all the context of rusty bolt. Or you go with a multimodal LLM that can understand that you're probably looking here for a wrench, but it struggles to precisely outline that wrench in this particular image. So you see, we have to improve the visual reasoning abilities of AI system. And luckily we have the latest research publication just from 2 days ago. Also, there's now a motto for this video: be the reason someone smiles today. And I hope it is you, because I'm gonna show you AI today and where we should be in the next days. This is here a simple synthetic image, and I ask here on Google a JAMA 327b, explain every item you can identify on this image. And I have to tell you, JAMA 3 is real good. Because it tells me central processor unit, the core, with the die, the silicon, the heat spreader, integrated heatsink, layer, components, circuit, motherboard, traces, lines, layers, connector, pads, particles closed, the waveforms, the color impressing, plus futuristic elements, holographic and wireframe appearances, the geometric shapes, the color palette, a highly stylized and artistic representation of a computer processor and its surrounding technological ecosystem. So not bad, no, for a free system. And you would say, hey, is this already, or is this still a visual segmentation of different objects in the image? Or are we already close here to a visual reasoning model? Now, 2 years ago, we coded together here in PyTorch a panoptic image segmentation with a vision transformer, and I showed you the mask to former, the specific code, and we took this image and we could then identify, look here, you see the segmentation for each and every person or thing or cardboard or car, and the degree of certainty which the AI could detect that this is a person 99%. So we know this for 2 years. So today we are talking, hey, what about, I say, identify the most crucial part in this image here of this CPU for the tensor calculation of a reasoning validation protocol. So I have now a task where the AI must do some reasoning. It must understand the object environment, the object attributes, the functions, the time series maybe of how the object will evolve. So we are talking now about a reasoning query that has a higher complexity. JAMA 3 comes back and says, hey, of course, the most crucial part in this image is the central processor, the CPU itself. Because the tensor operation are hardware driven, the silicon die is the computational engine, we have parallel processing on modern CPUs, and the protocol rely on speed and accuracy. Why not the other elements? So chain of thought, it is not a circuit board because this just provides connectivity, but it doesn't do the calculation. This is just the highway, not the engine, and so on. So chain of thought is really helpful here. And now you are familiar about this maybe. We talked about empowering here LLM, so large multimodal models, with a strong reasonability through a two-stage rule-based reinforcement learning. And you know, everything that is at the beginning of 2025 has to do with reinforcement learning. This is the absolute paradigm. But how do we have now this enhancing of a reasoning capacity in our large multimodal model? Because we face challenges. And we face challenges from this complex interplay between the visual perception and the logical reasoning. Now, in this particular paper, they found a solution that they use here a two-stage formula. No? The first, stage 1, the foundational reasoning enhancement, and then a multimodal generalization training. So they built one on top of the other, and then they went here with a classical RL policy optimization. Great. But this is a rather simple concept, no? But talking about simple concept, you know our good old friend, Liza. LISA is reasoning segmentation via a large language model. LISA stands for Language Instructed Segmentation Assistant, and LISA was the first model, to my knowledge, about reasoning segmentation. It's really a crucial task in multimodal grounding, requiring models to produce here those famous segmentation masks for complex implicit textual queries. I will give you an example in a minute. LISA was a model which tries to do everything at once. We put everything into LISA. LISA should do everything at the same time, and the output was just one special segmentation token to guide the segmentation model. And guess what? It was not the perfect solution. Just think of it solving in your head here a complex differential equation and plot the solution curve simultaneously in your head at the same time. Perform multitask in parallel. This is not the optimal configuration. Now, we have large language models. We have multimodal large language model with textual and visual modalities combined, but they remain incapable of generating precise segmentation masks. So we went on to referring segmentation models. I will explain them in a moment. They can identify the object boundaries, but struggle now in this particular view with high-level inference and reasoning, preventing them now from effectively tackling the reasoning segmentation. So the solution was to bring everything together under one huge umbrella of fine-tuning large language segmentation model on large-scale dataset. Extremely costly, extremely impractical, and it completely lacked scalability. So it was not really the perfect solution. And now the authors of today's paper, they said, okay, so we identified the two key limitations from LISA. It was the implicit reasoning, so the model's thought process for what it could choose is completely hidden. We don't know if it correctly reasoned for particular objects, and everything is entangled and squeezed into one model. So MLLM forced to learn about high-level reasoning and at the same time about a low-level spatial localization. And this is not how systems should operate. So welcome to the new paper of today, RSVP, Reasoning Segmentation via Visual Prompting, a reasoning-driven multi-stage framework that unifies now a multimodal chain of thought prompting with a visual segmentation. And you might say, hey, why so simple today? Well, we are just starting. Give me a second. Yeah, if you see here visual prompting, if you are new to AI, just 1 second of explaining visual prompting, have a look at this publication. A new prompting paradigm to unleash the detection ability of multimodal LLMs. It modifies here the input space using human perceivable markers such as bounding boxes, numbers, or shapes. And this helps here our multimodal LLMs to focus on key image regions without altering any model parameter. And this is great. It reduced the visual hallucination and a language bias. So this was here an interesting paper in the development of those models. And by the way, if we're talking about literature, this is a nice one. This is about Towards the Reasoning Era, a survey of long chain of thought for reasoning LLM models. And you also have multimodal chain of thought. And you see here 25 January, 25 February, and March, the amount of models that deal here with multimodal chain of thoughts. Of course, we cannot talk about it without SAM. So text-prompted segmentation, and I also told you it's called referring segmentation, involves now extracting here the object segmentation mask themselves based on the natural human language queries. SAM, Segment Anything model, was absolutely famous at its time, and we still use it today. However, those models lack here a structured knowledge summarization and a reasoning process between the text embedding itself and the segmentation for the mask. So they are also trained only on short, explicit queries, therefore, or thereby limiting their ability to handle more abstract and more implicit reasoning. So now that you know all of this, I think let's start. Let's start with this video. Let's start with the latest AI research. So what we do, we develop a more efficient modular reasoning segmentation framework that integrates now the multimodal inherent cognitive reasoning capabilities with the structured visual segmentation, and we do not need to fine-tune the whole complex. It is a simple two-step process. We start with a multimodal chain of thought visual prompting, I will show you this, which enables now our multimodal LLM to reason here about specific object attributes, and it will generate a region proposal. So this means it zooms in on a very particular region in the image, and it will say, this is the image, or this is the region in this image where we should be looking for the next step. The next step is the vision language segmentation module, which refines now those region proposals. And now from this particular small region, we have a further segmentation, and this now builds our exact segmentation masks. This is the study we are talking about, RSVP, June 4, 2025, reasoning segmentation via visual prompting and multimodal chain of thought. So we exploit here the intrinsic reasoning and the localization capabilities of multimodal large language model through a structured chain of thought visual prompting plus 3 or 4 other AI systems. Let's have a look at this. So you have a simple question. You have here an image of a snail, beautiful, and you say, the objects that can protect that snail and prevent it from getting injured are what? So on this image now you have a rough localization that, you're not gonna believe it here, that the multimodal LLM tells you in its linguistic capabilities, the chain of thought, yeah, this is the shell of the snail. Plus, since it's multimodal, it identifies here the localization of this object, the shell. So we have a rough localization, the reasoning comes in. The reasoning helps with the localization on the image. And then to get the absolute perfect, precise mask, we just have SAM segment anything model. And this gives us now here, and in blue, you have now the perfect mask. And the official answer is the shell is the protective covering for the snail's body. It is rather easy if you know all the components, if you know the strength and the weaknesses of all the components, and how you form them and squeeze them together to get here a model that outperforms everything else. So this reasoning segmentation is now the challenging task. And it is not about find the red car in the image. This is the referring segmentation that we know, and we know its limitation. This new stuff is now about segmenting an object based on an implicit complex query that requires common human sense, human knowledge, and a multi-step reasoning sequence. And the authors tell us, hey, our core insight, investigating, trying to explore this new element is to decouple the problem. We realized that the reasoning and the segmentation are two different skills, and it makes no sense to squeeze them into one model. So they created a two-stage pipeline where each stage uses here the best tool, the best AI system, the best multimodal system, the best SAM model for the job, without needing any fine-tuning. So great. So stage 1, you've seen it, reasoning and the rough localization. I call it the thinker model. No? If you want, this is the most innovative part here of this new paper. So the goal here is not to come up already in step 1 with the perfect mask, but to have here the multimodal LLM correctly identify the target object and tell now the second element, the artist, roughly in what regions to look for the object. And then at stage 2, the artist comes in with a precise segmentation refinement and can draw now the perfect segmentation mask. So stage 1, detail, multimodal chain of thought, the visual prompting. How do you get an LLM which thinks here in text, in linguistic elements? to talk about image location, it's easy. You just put a coordinate system over the image, no? Or a grid system, an overlay, whatever. And then the multimodal LLM can say, hey, the object that you are looking for is in vertical segment 4, 5, 6 and in the horizontal segment 5, 6, 7, 8 of the image. Problem solved. And the model, the multimodal chain of thought tells us then, I don't just infer the object, I don't just locate the object in the image, but it also provides here a rationale. The reason why I identified the correct object is, and this object has the specific feature, and this object is used in, I don't know, in a social context in the following form. So you have a rationale that explains here the form, functions, and everything of this particular model. Now, the output is easy, no? You have a textual description of the target, you have a set of horizontal and vertical region IDs, and you have an explicit, human-readable reasoning. And stage 2 is easy. You just use here the vision language segmentation module that you know. You crop the image to the region of interest. You use here a vision language encoder, a B3, and then you have a segmentation. You have your classical SAM model, and in the end, you have an expert, precise pixel mask of the object. Congratulations, you succeeded. Now, if you're not really familiar with BERT, easy BERT, pre-training of image transformer. BERT exactly stands for bidirectional encoder representation from image transformer. Following here the BERT development in the natural language processing area, long time ago, the authors proposed the mask image modeling task to pre-train the vision transformer. And as you can see, it is still valid today. BERT, which stands for bidirectional encoder representation for the image transformer, is still in use today. Yes, even has a valid GitHub. Although I have to tell you, last input was March 2023 for BERT version 3, but you get the idea. Now, interestingly, this is where the story gets really exciting, because the authors now testing this out, they found something. And they said, you know what? At first, we could kind of validate this hypothesis that at first we separate here the task to their particular tools, to the particular AI systems. And then we found that if we just improve here the step 1, the thinker, the reasoning stage, and we do not improve the stage 2, the performance got much better, the better the reasoning process was. And they tested this extensively, and in the paper, have a look at it. You have hundreds here of test data, parameter, validation data, test sets here to demonstrate all of this. I just give you here the result. And as you see, all the different methods, and here the last 4 lines in the new model, the RSVP model, either you went with a Lava 7B, a Q1.2 Vision Language 7B, a Gemini Flash, the old one, or a GPT-4 Omni, also an old one, you got the best results, of course, with the latest methodology. And they said, hey, with reasoning, so using here the stage 1 process, this massively outperforms everything else. So do not use the without reasoning, a simpler method, because you lose performance. And this also kind of proves here the decoupling hypothesis that the quality of stage 1, the reasoning, coming now from the reasoning capacity of the multimodal large language model, drives here the quality of the segmentation. So you see the importance of reasoning. If we get reasoning right, then every other domino falls into place. No problem at all. If we have one inherent system failure in the reasoning process, it will through the complete visual reasoning system, and yeah, performance is gone. So therefore it is so important to get the right reasoning model just on the linguistic side, on the LLM side. Yeah, they said if a visual prompt with a grid-based 9x9 was optimal, beautiful, you find here all the data. Yes, you can imagine now the horizontal grid and the vertical grid and how you build this. And then they give you here the exact chain of thought prompt applied here to experiments where you ask here the system, hey, Give me here the instance, give me the idea, the vertical ID, the horizontal grid IDs where the object is located, give me now the complete reasoning, and the AI provides all this information for you. Here I've shown you here a final result. So you start with an original image and you say, I don't know, okay, if the horse is jumping over what particular object, show me or identify the object. So you have at first a horizontal visual prompt and you build a vertical visual prompt for the multimodal large language model. Then you have, if you want, a zoom in on the region, a visualization of the region where the object in question is located. You see here, this on the bottom of the image, and then you apply a SAM model, a segmentation model, and you get exactly location of this element, of this object, that is the content of your query. You see, as easy as can be. Now, of course, you know we do have limitations, no? And it depends on the quality here of the multimodal large language model, especially on the reasoning performance. It all depends on the reasoning performance. The better it is, the better is the complete system. No, we have not yet found the optimal visual prompt design. Maybe we should apply some DSPy optimization. But in general, I think it's a beautiful piece of engineering that the author showed us here to solve a problem, but not by brute forcing here our solution, but by cleverly decomposing the complexity into two parts. You say, hey, I have one AI system that can do part A great, and I have another AI system that can do part B great. So decomposition or decoupling here is really key for the success. You have the visual prompting, as I just showed you here, as a bridge function, and you have explicit reasoning that enables you to really validate also as a human readable text that you can immediately debug or identify any problem with the reasoning process. And I kind of like this example. You know, it's not complicated. It is not that you say, my goodness, it will change the world. But it is a nice prime example of a philosophy where you say, don't brute force your way into a solution. Build intelligent pipeline with the right connectivity, with the right AI system, with the right tools, and where you have specialized components that will collaborate and will solve the job given. Therefore, I hope you enjoyed this video. If you want to see more, why not subscribe? And I see you in the next one.